So this is the Math Praxis workshop. All right, so let me go ahead. I've given this out to everybody. Let me give you one here. There's a mathematics study topics, which you might have already seen.
Yes.
This is a practice test that came from ETS that I got. So what we're going to do is just walk through real quick all the different topics. I'll try to do that quickly so we don't spend a lot of time on it, so we can actually start working some problems. But these are the actual mathematics study topics. And I just wanted to point out, I'm going to go ahead and reduce that a little bit so we can see more of them at a time. So let's go ahead and reduce that. All right. Actually, that's not going to work. Okay. Okay, it starts with over here on the right, number operation algebra. Most people are actually better at algebra than they are at just geometry and probability, but you've got your basic number for algebra, you have your basic number systems. You need to be very familiar with base 10. They'll ask a lot of questions about base 10 on there. And fractions, if you guys struggle with fractions, that's something you're going to have to get good at because there's lots of stuff with fractions on this test.
I just learned how to do it from Khan's Academy.
Okay, good, perfect. Whoops, what happened there? This is a really detailed. I'm just going to kind of try to synopsize. What is the word I'm looking for when you're an English major? When you try to condense everything. Well, condense it. I'll use the word condense. That works. Condense everything. So you have. Let me go down here. You have number theory, like I said, and you have numbers. You have prime numbers. You need to know the difference. Prime numbers, composite numbers. I guess I'll just go across as I do this, so I don't have to keep going up and down. Odd and even numbers, solving problems and assessing results. A huge part of this test is being able to read a problem and actually interpret what it's saying, because they rarely actually ask you a straight up question that you could like just plug into a calculator and answer. Those things aren't happening. I have honestly not seen anything with Pascal's triangle, but I've seen lots of sequencing. There are tons of geometric figures that you have to do patterns on. Let me go back down with that real quick. I skipped pages somehow. I went down. Yeah, let's see. Reciprocals, signed numbers, properties of zero. You guys all know you can't divide by zero, right? Mm-hmm. But you can divide into zero.
You can divide into zero.
You can divide into zero, but you can't divide. Yes, that's right. Equalities and inequalities. You need to know the less than or greater than symbols. Associative and cumulative, distributive. Are you guys familiar with those properties?
Yes.
Okay, those are critical that you need to. They'll ask you questions. Which property does this display? That's very typical of this question, so if you're good with that, that will help. The additive and multiplicative inverse. What's the additive inverse?
Additive inverse is when you add the opposite of...
the opposite sign, right. When you the additive inverse should give you zero.
Right.
So when you add a number and its inverse, you get zero. When you multiply a number and its inverse, you get... These are the kind of questions they ask. The multiplicative inverse gives you...
the negative, right?
No, that would be...
1?
Yes, yeah.
Okay.
So like an additive and multiplicative inverse would be multiplying 2 over 1 times 1 over 2.
Okay.
So the multiplicative and additive inverses are reciprocals of each other, basically, is what it was. The same sign, you don't change the sign. Reciprocal, when you multiply, you get 1. And we'll do some in just a minute like that. That was one of the more basic ones. Geometry and measurement. Here's a bunch of different shapes and measurements you need to know from geometry.
That circle thing I always be confused on. That sphere.
Yeah. When you look at your test, when it breaks down what you did?
It was geometry and probability was the
Okay,
ones I had.
that's actually what a lot of people come through. So we'll spend a lot of time in geometry and probability because that is where people have trouble. So there's geometry, there's some probability, quantitative analysis. There is some statistics. How are you guys at statistics?
I've never had a statistics class.
You've never had a statistics class. Okay, well,
I've never been really good at math, honestly. So.
Yeah. Generally speaking, when people look at the test, it's not the algebra that gives them the trouble. It's the geometry and the statistics. So let's go ahead and look at this test. I actually have, you guys have it in front of you. So I'll go ahead and go to the next page, and we'll go ahead and start working some problems from the test. I'm not going to pull it up on here. Okay, so here's a geometry question. Triangle ABC, the measure of angle A is 47. You have to just, basically what a lot of this runs on is you have to remember the properties, oh, there it goes, of triangles. There's basically three things. First thing you need to remember is the area of a triangle is 1/2 base times height, or it's base times height divided by 2. Either way you want to think about it works. Okay, so you need to remember the area of a triangle. The second thing you need to remember is that the sum of the interior angles is equal to 180, right? And then is there anything else you know about a triangle? You've got different types of triangle.
Isosceles.
Isosceles, right. The big ones are isosceles, equilateral,
And acute.
and yeah. Did they ask you something about acute? Have you seen acute questions on the test
I
previously?
think I've seen scaling.
Yeah. Okay, well, let's go through. So you've got scaling. These are types of triangles. That's not a very good triangle, but that's all right. So you've got scaling, which means what?
It's a scale. It's like a scale. It was
All sides
outside.
are not this. All sides are different. Are different lengths. All right. That's the definition of scaling. I hope I'm spelling lengths right. I always mess the way I spell. Which means all angles are different measurements.
Oh, okay. Somebody described it as something that it's something about a scale. Is there any definition with a scale?
To scale? Something being to scale?
I don't know.
No, I'm not sure. I don't know how scaling would work with scale, so to be honest. Yeah, I don't know the connection there. Are different, okay? Now, what you have to do on this test, I've seen several versions of it, and I was actually part of the state group that worked on it, is you have to use what you know to answer these questions. They're not going to give you straight up questions, right? So they may give you a scaling triangle. Here's a scaling triangle. What you need to know is that all the sides are different. The other thing you need to know is the angle measure opposite the side is basically proportional to the side itself. So the smallest angle measure will be opposite the smallest side. The largest angle measure will be opposite the largest side. Okay? So, and the other thing that's really important about triangles, we talked about the sum of the interior angles is equal to 180. Is 180. Okay, so that's true of all triangles. That's not just of scaling, and it's true of all triangles too, that the opposite side is proportional in relationship to the angle itself. All right, so that's scaling. The other type of triangle that you have would be a right triangle. This is another huge classification of triangles. And the things that are important about a right triangle is what always is true. Why is a right triangle called a right
Isn't
triangle?
it always 180?
You always have a right angle.
Right at 90 degrees.
Yes, 90-degree angle, all right? There's always a 90-degree angle somewhere. It has to be. Now, what they do is they will not give you a right triangle that looks like that. They'll give you a right triangle that looks like this, okay? Where the angle is up here, I guarantee you. They never make them pretty like that. The other condition that's really important is if you know this is a right triangle, what do you know about the other two angles?
One of them equals the sum of 180, right? 'Cause all of them.
Well, you know the whole thing is 180. If it's a right triangle, you automatically know what about A and B. Yeah, A plus B equals 90. So they may just give you one angle measure and they tell you it's a right triangle. From that, you can automatically figure out what the other one is. Does that make sense? And those are the kind of questions that they'll give you that you have to use what you know about triangles to solve. And that's really one of the core parts of a praxis, is you have to use what you know to answer the question. You don't use what they give you. They give you enough information if you know the properties themselves. So that's a huge part of the right triangle, right? Is that you have that 90-degree angle. You also have formulas that come off of the right triangle that are specific to the right triangle, and that would be your Pythagorean theorem. Let me call this angle 1 and 2 instead of A and B, because the Pythagorean theorem usually works off of A and B. So we'll call this 1 and 2. Okay, and I'll go ahead and call this 1 and 2. Okay, so you also have your Pythagorean theorem, which says that if you have A, B, C, is the generic, usually the way you call it. In this case, where's C in this triangle?
Across from the right angle.
Yeah, it's always opposite the right angle. Is
So
always
that's
your
like
hypotenuse.
hypotenuse?
Yes. Exactly. Yeah, C is what I'm calling hypotenuse, right? You can call it H if you want. Variable is just a replacement for whatever, so you can call it anything you want. The Pythagorean theorem, instead of A squared plus B squared, I would remember it's side squared. I spelled side wrong. Plus side squared equals hypotenuse squared. Okay, that's a huge formula, and I guarantee you they're going to ask you questions on that particular formula, because that's just what they do. It doesn't matter which side you do first. Addition is commutative, so you could do A squared plus B squared, or you could do B squared plus A squared. But this has to be C squared, okay? So that's a really big property of, you guys are not going to have to do any cosine stuff, so that's good. You're done with that, all right? Another type of triangle that was a right triangle. You also have the isosceles. They use a lot of questions that I've seen on this isosceles triangle, all right? Which tells you that these two sides, usually it's an X and this is an X, right? Those sides are always the same. I'll call this B. And there's several questions I've seen that involve the area of a triangle if you're given an isosceles. Because all you need is, let me show you the kind of problem that I could see you guys getting. So they give you something like that, and they might tell you, let me see if there's one in here in the questions, because I think there might even be an isosceles question. Triangle. Dividing. Actually, let me search for isosceles on this problem, because I really think the wording on this is like I said, it's always unique. So let me go to edit find, and I'll look for isosceles. isosceles, is that right?
Yeah.
Okay. I don't want it for the page. All pages. There we go. Let's see if it's finding. Did it find isosceles? It may not have isosceles in here. That's 40. Okay, never mind. They don't have isosceles in here, so let's go ahead and just stop it. Okay. All right. Let's go ahead and go, and I'll just go ahead and make one up. Okay, so this is the type of question that you could be asked. I'll go ahead and just throw one out there. I don't know. Isosceles may be in here somewhere. I just can't find it. Okay, so this is the type of question. This is the type of question that you would be asked. You would be told something to the effect of, I'm trying to remember how these are worded. If you are given an isosceles triangle, whoops. And let's see, how do they say it? They usually give you just one side. They give you, how do they do that? Oh, I can't make these things up because I don't remember exactly. But anyway, they'll give you, let's say they'll tell you once the base or something, they'll give you, let's say the base is twice or is 1/2 of the length of this side, or one of the duplicate sides. Let's say duplicate, all right, because they have to somehow tell you that this is one of the sides that has the same measure as the other side. on the duplicate sides, right? So what you know is if this is, and then they might say find the area. This is the type of question they give you, right? So they haven't actually given you very much information, but you have to use what you know. Well, you know that if the base is half of the duplicate side, that makes the base equal to what? If we're going to call, they don't tell you how much each of the sides are, so we're going to go ahead and these are going to just let those be x. So this would be what?
1/2 x.
Yeah, this is going to be 1/2 x, all right? Does that make sense? You have to kind of use common sense looking at these and ask yourself, what's half of that? Then we got to call it something. You could call these both s. It doesn't matter what you label it. So if it wants the area, you write down your area formula. What's the area of a triangle?
1/2 base times height.
Yeah, and then you have to put in what you know. Well, you don't know a lot, but you know what, you got something up there. So what do you know?
B.
You know b. What's b?
1/2 x.
Yeah, 1/2 x. And then h is, you don't know h actually. So h, this is where these can get really convoluted. You have to actually use the Pythagorean theorem to find the height. Do you see where I'm going with this? So what's the Pythagorean theorem? It says you've just turned this into a right triangle. Okay? So there's your right triangle. So what is the Pythagorean theorem say? What is h? That's the height, your altitude.
Wouldn't be one side squared
Yep. Good.
plus side squared
Let's just do
equals
s. Yeah. S squared plus,
s squared.
yeah, we'll say s1 plus s2 squared equals,
Okay.
yeah, in this case, hypotenuse squared. Okay, so on this picture, where is the hypotenuse? What have I labeled the hypotenuse?
Is it the base?
It's across from your right angle, it'd be h, it'd be x.
Oh, okay.
When you make these right triangles, you cut the middle, the height altitude is always perpendicular to the base.
Okay.
Otherwise, it's not altitude. So that's going to be across from your right angle, which makes it x.
Okay.
Okay, so your hypotenuse is x squared. See what I'm doing?
Mm-hmm.
Okay? One of your sides is going to be what? I've already...
Half of x.
Okay, well, it's going to be half of the base. The base is half of x, so what's half of half? A fourth. Yeah, think it's dollars.
Okay.
Half of $1 is 50 cents, half of 50 cents is 25. So we're talking about a fourth, right? You see what I'm doing?
Right.
Okay, so we have 1/4 squared, and then we have and then we have the height, which is what we don't know. So it's going to be 1/4 of x squared. And then we know we have h squared, all right? So that's the information you would use. This is going to get really convoluted now because I made this up, all right? So this, you'd have to solve for h. This is harder than anything you'll get on your Praxis, but this was actually diagramming the things you're going to look at, okay? Let me actually do one before we finish because this is harder than what you would get. But I did want to make sure you made the connections, all right? Whenever you have a triangle, a lot of times you have to use a Pythagorean theorem to cut the triangle in half to get the height. So you use, this is a side, this is a side, this is your h. A lot of people mistake and make that for h. Or they might have even told you the height. They might have given you the height. I mean, they'll give you different things, but you don't know what they're going to give you, so you have to make sure you have this relationship straight. And a lot of times you have to use this relationship of your Pythagorean theorem and combine it with the altitude, all right? So this is going to be whatever h was. It's going to be h. We just don't know what h is. Okay, so I'm not going to, I could keep going. This is going to go way into the weeds, deeper than you guys need to know. But as long as you understand the relationship, that's what you're looking for. So this is huge. Isosceles triangle builds constantly off of the fact that you know two sides are the same length. And that you know that the base, if you make a right triangle, half of the base is going to be part of your right triangle. Okay, and that's how you go to find the height. Does that make sense? So if I gave you numbers, let's do one with numbers. If I told you, and this might actually be closer to what you would get. If I gave you that and I told you, basically you're told something about a isosceles triangle where you know this side is 5 and then you're told the base is like 15. This is not unusual. That does not match the picture at all. A lot of times they will give you information that's not, if you follow the picture, it will confuse you. So you have to do what you know. The more appropriate way to draw that would obviously be do something like this, right? Where you have a short, actually, I don't think we can have sides that small. Let's turn this into 5 and 5, it has to, let's do 9. Okay, so there you, whoops, and you're only told one side, so you have to use the property of isosceles triangle. Tells you that the other side is 9. This is all the information they'll give you, and they'll ask you for the area. Okay, so this is more probably closer to the kind of question you're going to get. So what's the area of this triangle? Well, what do you know automatically? You got to go through what you know. What do you know now?
You know, base.
The base is, what can you fill in automatically right now? I mean,
9 on the other
yeah, you know
side.
this is going to be 9 as well, right? And what else do you know? You know that if you cut this right down the center, that it's going to split this exactly in 2. Now, it won't do that with just any triangle. It only does it with isosceles and equilateral because these are the same on each side. So you know that that looks like, right? So follow the train of thought. So we have that. What else can we do here? I'm going to turn this into a 16, and you'll know why in a minute. Why did I turn that into a 16?
The whole number.
Yeah, it's an even number, because why do I care that this is an even number? I just cut that down the middle because I need to know the height for the area. So what do I need for the area?
You have base.
Yeah, I need to use the Pythagorean theorem for this half, right? So I'm going to be looking at this half of the triangle. I made this 16, so we're not working with a fraction. 16, half of 16 is 8, all right? So over here, I'm going to pull this out. I know some information about this triangle. I know this is 8. I know this is 9, and this is my h, right? So how can I find h?
Isn't it 9 squared times 8 squared? Or
Now,
9
this is
squared?
where you have to be careful. Your hypotenuse is where?
Oh, 9.
Yeah, always check to see where your hypotenuse is, because you got to remember it's not h. H is actually a side. And that's an easy mistake to make. So we know it's going to be h squared plus
9 squared.
8 squared. Yeah, this is a side. Your sides are always connected to the right corner.
Okay.
To the right. That right angle is the sides. And then you've also got, and then h is, in this case, not h, 9 is your hypotenuse. Okay? So we have, what we know is we know 8 squared, and I can go ahead and subtract 8 from both sides, right? So I know 8 squared is equal to 9 squared minus 8 squared. So 9 squared is what?
81.
Yeah, 9 times 9, right? Versus 9 times 2. This is a 9 times 2. This is 9 times 9. 8 squared is 64. And h squared is equal to that. 81 minus 64. 80 minus 60 is going to be 20, right? So you're actually... Well, yeah, you subtract 80 minus 60 and you get 20, but then you're subtracting 4 less, so that moves you up to 16. But then you're adding 1 on top, so that's going to move you up to 17.
17.
Yeah, 17. And you guys get calculators, so you can do that. So h squared equals 17, and then you have to be okay with the next step. What is h?
You have to divide by 2, right?
Nope. H is equal to, what the heck just happened there? Why is it doing that? Am I too close? There we go. H is equal to, how do you get rid of a square?
Oh, you should multiply both sides by 2.
No, you do square root.
Oh, yeah.
Yeah, this is the square root property. Whenever you're trying to take care of a square, you're going to take a square root.
So does the answer like that?
That's just h. And this is a problem. You had to find the height because remember what was the original question?
Area.
What's the area?
What's the area? What is your area formula?
1/2
1/2.
base times height.
Okay, so the area formula is 1/2 base times height. So you have the base, right? The base is what?
Square root of 17.
Well,
Oh, no,
your triangle. What's the base?
16.
Yeah, the base is the original 16, so it's 1/2. You already knew what the base was, but you didn't know what the height was. Now you know the height. It's what?
6. The square root of 17.
Yeah. And so that ends up giving you what when you simplify easier part? What does that give you when you simplify? Don't worry about the square root of 17. You leave the square root as the answer will be in terms of the square root of 17.
It'll be 8 times the square root.
And that's going to be the answer. That's going to be in one of your slots. That will be an answer in a slot. Okay? Does that make sense? So whenever you have a square root or you have pi, you just leave it alone. Do not, unless they tell you to replace pi with 3.14, your answer has to have pi in it.
So they'd probably have that, and then the actual simplified answer.
No, they won't give you a decimal answer. Because people round and that's kind of leading you astray. They'll have, what will they have? I don't know. I have to look at the questions and see what the distractors are. But this is what the answer looks like. Whenever you have a root, you move it as a root. That's the actual correct answer. So you don't want to fool with that at all. Okay? And that's just an example of how you use what you know with triangles to answer the question. All right, if you look at question number 2 on this sheet, let me go there. Oh, that's the wrong one. Hold on. If you look at question number 2, you're going to see, okay, right there. Triangle ABC, the measure of an angle A is 47, the measure of angle B is 53. What is the measure of angle C? What property are you going to use to solve this?
That each triangle adds up to 180 angles.
The angles of a triangle add to 180. Did you see what I'm trying to get you guys? You have to use what you know about general properties of triangles to answer these questions. Because they're not going to ask you something that you can just like automatically, oh, I've seen this before. No, you want to have seen a bunch of them before. Does that make sense? So you have to think, what do I know about triangles? You have to have these properties in your mind.